Okay, so we're going to start off with one-step equations. We're going to do one-step addition, subtraction, multiplication, and division equations. So we first must consider the whole goal of solving an equation. To solve an equation, you must get the variable by itself. Another word for variable is a letter, but you got to get it by itself. And then once you get that variable on one side of the equal sign by itself, you can consider it solved. It says what side is the variable on, and what do you need to remove? And I mean, what do you need to remove in order to get the variable by itself? So I always have my students draw lines. The variable is on the left side of the line, and the only number I need to remove to get the variable by itself is this positive 7, okay? In this particular case, draw your line on your equal sign. The variable is on the right side of the line, and the only number I need to remove to get the x by itself is the number 5, okay? On C, if you draw your line here, I can see that the variable x is on the left side of the line, and the number I need to get rid of is 3/4. If you look at D, the variable I need to get rid of is on the right side of the line, and, the variable I want to get by itself is on the right side of this line, and the number I want to get rid of is -5. So if I didn't have that -5 there, x would be by itself. Or in this particular case, if I didn't have this 7, x would be by itself. Or if I didn't have this 5, x would be by itself, okay? So that's the first thing. You have to decide what side of the line your variable is on, and you have to decide what to get rid of. Now, how we get rid of it is the next question. So let's take a look at this one. It says to get a variable by itself, you're going to use an inverse operation, okay? So this is going to help us get rid of the number that's on the side with the variable. Using an inverse operation helps us get rid of that number. So exactly what is an inverse operation? Well, inverse operations are operations that undo each other. So if it's addition, you can undo it with subtraction. If it's subtraction, you can undo it with addition. So addition and subtraction are inverses. They undo each other. This will always involve a sign change. Multiplication and division are inverse operations. And be careful because this does not involve a sign change. There's no sign change there. So keep in mind, if you're trying to get rid of something that's added or subtracted, it involves a sign change. Okay, I'm going to show you something too. If it's not attached to the variable, you just need to change the sign. Things that are not attached means that they are added or subtracted. So you can just change the sign, okay, to get rid of it. But now if it's attached to the variable, then that means you're either multiplying or dividing. Okay, if it's attached to the variable in some way, it's multiplication or division. If it's not attached to the variable, that means it's addition or subtraction, and all you need to do is change the sign. So let's take a look at this one. Is 7 stuck to my variable? Is it attached to the variable x? No. That means it's addition or subtraction. So if it's addition or subtraction, the basic thing is just to change the sign. Change the sign. So I would change the number that I want to get rid of. I want to get rid of positive 7. I would change it to a -7. Here the variable is on the right. I want to get rid of -5. But -5 is attached, okay? That means it's a multiplication or division. When it's attached to the variable, it's multiplication or division. So if you don't know this, anytime you see it mashed together, that means it is multiplication. And I want to be able to write it all the way out, but I'm trying to write multiplication. Okay? Anytime it's mashed together, it's multiplication, guys. So if I look at these two, the number and the variable mashed together, this means that it's multiplication. So how do you undo multiplication? So to undo multiplication, you do the inverse of multiplication, which is division. So what I would do, and to show division, guys, use a bar. This bar shows division. So you divide by -5. However, you make sure you do not change the sign. You only change the sign if it is not attached to the variable. Not attached, change the sign. In other words, if it's farther away from the variable, change the sign. Or separated with a plus or a minus, change the sign. Okay? And let me do something on this one. So back on A, 7 was not attached. So we just need to change the sign. So you would just put -7 or -7. Okay? If you look at C, this is so much better. If you look at C, to get X by itself, I need to get rid of -5. But what did I tell you this bar means? So if you draw a bar like I did on B, if you draw a bar, that bar means division. Or if the bar is already there, it means division. So if it's division, the opposite of division is multiplication. They're inverses or opposites, okay? You do not change the sign. So what I would do, instead of dividing by -5, I would simply multiply. I'm going to use a little dot to represent multiplication by -5, but do not change the sign. So what I would do, instead of dividing X by -5, I would multiply X by -5. Again, I'm going to go back to B. It was mashed together, so it's multiplication. So here, instead of multiplying by -5, I chose to divide by -5. And to show division, we draw the bar to show division, okay? Underneath the term. All right, look at D. All right, if you look at D, here's your X. You got to get rid of -15, but -15 is not attached in any way, and there is no division bar. So if it's not attached in any way, that means it's addition or subtraction. So all you need to do is change the sign. So -15 or -15 would change to +15. If you look at E, here's your variable, okay? -11 is not attached to it in any way, and there's no division bar, so all you need to do is change the sign. That's it. So -11 will go to +11. So if it's not attached, notice that all we did was change the sign. Not attached. Change the sign. The 15 was not attached. Change the sign. Okay? This +7 was not attached to the X. So all we did was change the sign. That's it. Okay? Now, since we understand that if we have a number that's not attached, we just change the sign. If it is attached anyways, for instance, if it's mashed together, you divide. Okay? If you see a division bar, that's your division bar, you multiply. So if you see a division bar, make sure you multiply. And to multiply, we just use a little dot. If it's mashed together again, that is multiplication, so you want to use your divide bar. And your divide bar goes in the middle, in between the -5 of the number that is with the X and the -5 of the number that you write. Okay? It goes in the middle. Remember that. All right, says the third important thing is what you do to one side of the equation, you must also do to the other side. So notice up here on A, I subtracted 7 from both sides, but I didn't do it. I didn't cross the line and do it to the other side. Or on B, I divided by -5, but I didn't cross this line and do it over here. Okay. On C, I multiplied by -5, but I didn't do it over here. On D, I put a plus 15, but I didn't do it over here on this side of the line. And on on E, I put a plus 11, but I didn't do it over here. So this tells me I need to go back, and whatever I did on one side of the equation, I also need to do on the other side of the equation. So I'm going to go back and complete A through E. So let's go back up to A. So to get rid of plus 7, since it wasn't attached, I changed the sign. But if I put -7 on the left, I got to cross the line and put -7 on the right. And this is positive 10, and that's -7. The signs are different, so I subtract, and I have more positives and negatives. So my answer is 3. I know you know that 3 plus 7 is 10 anyway, but I need you to show your work. On B, it was mashed together, which indicated that it was multiplication. So I did the opposite or inverse, which is division. When it's division or multiplication, make sure you do not change the sign. So that's why I kept the -5. You only change the sign if it's not attached. So if I divide by -5 on the right, I got to cross the line and divide by -5 on the left. These cancel, and I'm left just with x, because these are gone. Okay, now for multiplication and division, you got to use the smiley face, or same positive, different negative. So I'm going to do the -10 divided by -5 is positive 2. All right, on C, I saw a division bar, so I multiplied. So instead of dividing by -5, I multiply by -5. Remember, on division and multiplication, we do not change the sign. So if I multiply, remember using a little dot for multiplication. If I multiply on the right side by -5, I got to multiply on the left side by -5. And for multiplication and division, use your smiley face. -5 times -3 is positive 15. I need to go down a little bit. And these are going to cancel out, and I'm just left with x. All right, on D, that 15 was not attached. So if it's not attached, remember, all we're doing is changing the sign. So -15 changes to positive 15. But if I do it on the left, I also have to go on the right and do it. So I can't just put plus 15 on the left, on the right, excuse me. I did that backwards. If I put plus 15 on the right side, I got to put plus 15 on the left side, okay? Or left side of the line. So go over here and put plus 15. Now, if you're changing the sign, we all know that's addition and subtraction. So you got to use the fact that if they're the same signs, add and keep. If they're different signs, subtract and take the sign of the larger number. So this is negative, and this one is positive. So since they're different, I'm going to subtract 15 minus 12 is 3. But I got more positive, so it's positive 3. And these cancel each other out, and I'm left with x. Excuse me. Okay, on E, I noticed that the number was not attached, so all I do is change the sign. So -11 changed to positive 11. But what I do to one side, I do to the other side. And these are both positive, so you can add them and keep the sign. Everybody knows 8 plus 11 is 19. And I'm left with just x. All right, so the rest of this, we're going to just solve some varied types of equations, and then we'll be finished, okay? So let's take a look at 11. First of all, I want to know what side the variable is on. Well, the variable is on the left, and I need to get rid of -12 or -12. I don't care how you read it. But that number is not attached to x. So all you do is change the sign. That's all you do. So put plus 12, but what I do to one side, I do to the other side. Those cancel, so I'm left with x, bring that down, equals 2. Now, if you're changing the sign, that means all it was addition and subtraction. So I just got to label it. This is negative, and this is positive. Okay, they're different, so I'm going to subtract. Now, is the bigger number on top already? Sure, 46 is bigger than 12. So 6 minus 2 is 4. 4 minus 1 is 3. And you got more negatives than positives. You got to be careful on something like number 2. The reason being is because this double negative is a plus. Okay? So basically, guys, this is just x plus 5 equals to 19. That's really what it is. So I'm going to work this one. Well, plus 5 is not attached. So again, if it's not attached, all you're going to do is change the sign. Tyler, what number you on? You're done? Gotta wait on me, I'm sorry. You gotta change the sign. So I'm gonna change the sign of plus 5 to negative 5. These, and what I do to one side, I do to the other. And then 19 minus 5 is just regular subtraction. You get 14. All right, 3. You have x plus negative 10 equals to 12. Well, x plus negative 10 is just the same as a negative. You don't even worry about trying to rewrite this. It's the same as negative 10. So what I want to do, I realize that negative 10 is not attached. So all I do is change the sign. Now these on number 2, I want you to rewrite this double negative as a plus before you start working. On number 3, you don't have to rewrite plus negative. We see that clearly that's negative 10. All right, so instead of adding negative 10, I'm going to change the sign and put plus 10. But what I do to one side, I cross the line and do to the other. These are going to cancel, and I'm just left with x, and 12 plus 10 is 22. I'm done. I'm trying to write this a little better so you can see it. All right, on number 4, these are mashed. Negative 8 is mashed together with x. Okay, if it's mashed together, it's multiplication. To undo multiplication, remember that little dot stands for multiplication. To undo multiplication, you need to divide. To divide, we use the divide bar. So you just draw your bar, which stands for divide. Okay, and don't change the sign. Do not change the sign. We never change the sign on multiplication or division. We only change the sign if it's not attached to the variable in any way. So I'm going to divide by negative 8. But if I divide by negative 8 on the right, I must divide by negative 8 on the left. And then if I'm doing multiplication division, I switch back to a smiley face. Negative 64 divided by negative 8 is positive 8. And these just cancel each other out, and I'm left with x. On number 5, 7 is attached to x in some ways underneath it. I see a divide bar. So if you see a divide bar, I need you to multiply. And remember, there's your divide bar. Your divide bar is always in the middle. All right, so if it's division, you need to multiply, but we do not change the sign on multiplication or division. So what exactly is the sign of 7? Well, it looks like positive 7, but you see this negative is with your divide bar? It's actually supposed to be with the 7, so just rewrite it so you can tell that negative is actually supposed to be with your 7. Signs should be with your number, guys, not with the division bar. So just rewrite it with the number. Okay, now, so instead of dividing by negative 7, I'm going to multiply on both sides by negative 7. And these are going to cancel each other out, and I'm left with x. Now, if you multiply, use your smiley face. So you have a positive 12 times a negative 7, which leaves you with a negative 84. And that's all you do. Okay, let's take a look at 6. 6 is written fine because I have division, and this negative is with my number. 7, on number 5, the negative is with my bar, so I rewrote it with my number. So if I have division, I need to do the inverse or opposite, which is to multiply. But on multiplication or division, do not change the sign. Only change the sign if it's not attached. So if I see negative 5, and I just wrote that this means division. So since that means division, multiply. So if you see negative 5 and we're not changing the sign, then you multiply by negative 5. But if you multiply by negative 5 on the right, you must multiply by negative 5 on the left. These cancel. And I use the smiley face. Negative 5 times positive 8 is negative 40. Make sure you're showing your work. All right, go back to 7. On 7, the variable is on the right. It's over here on the right side. But negative 24, the number that's over there with it, is not attached. So if it's not attached, all you have to do is change the sign. It's not attached to the x. So all I have to do is just change the sign of negative 24 to positive 24. And if all you're doing is changing the sign, that means it's addition or subtraction. So I'm just going to label that this is negative and this one is positive. Okay, if they're different signs, I need to subtract, but 24 is my bigger number. It's on the bottom, so I'm going to have to do a little side work and rewrite it. 24 minus 14 is 10, and it's more positives than negative, so it's positive 10. These cancel, and I'm left with x. Okay, I got to go to number 12. Okay, on number 8, my x is on the left side, and it's mashed together with negative 2.5. If it's mashed together, that means it's multiplication. So if it's multiplication, I need to divide. But when we multiply and divide, we do not change the sign. Do not change the sign. So since it's mashed together, which is multiplication, I need to divide. So draw your divide bar on both sides and divide by the number you're trying to get rid of. Well, I'm trying to get rid of negative 2.5. You're always working with the number you're trying to get rid of or the number on the side with x. So if you divide by negative 2.5 on the left, you got to divide by negative 2.5 on the right. These are going to cancel, and I'm left with x. So on this one, I'm going to have to do in and out. And we worked with basic skills last week. I need to erase this, guys. So since we worked with basic skills last week, let's go ahead and divide. But we know we can't, we should know we can't divide by a decimal. So I'm going to scoot this to the right once and scoot that to the right once. So now that's going to be 25. And instead of being between the two zeros, the new decimal is in between the 0 and the 6. And bring your decimal up. 25 won't go into 0. 25 won't go into 6, but 25 will go into 62. 2 times, that's 50. And 25 goes into 125 5 times. 5 quarters make $1.25. So, and always use the smiley face on multiplication and division. Negative divided by negative is a positive, so that's going to be positive. Okay, let's take a look at 9. On 9, the 1 and 2 X is right here. And then 1 2/3 is not attached. Okay, so all I do is change the sign. So I'm going to change 1 2/3 to -1 2/3. These cancel. But now, to add or subtract fractions, you need a common, to add or subtract fractions, we need a common denominator. So I'm going to have to do a little more work on this one, on number 9. So one denominator is an 8. The other denominator is a 3. So I'm going to do a T-chart and skip count. 8, 16, 24, 32, 3, 6, 9, 12, 15. I'm not close to even 32 yet. Keep going. Or I'm not in my 20s yet either. All right, 18, 21, and 24. There we go. So your common denominator is a 24. So 8 times what gives me 24? 1, 2, 3. So multiply this by 3 and that by 3. That means I can rewrite that as 4 and 21 over 24. And then 3 times what gives me 24? That will be 8. Or you just count 1, 2, 3, 4, 5, 6, 7, 8. Multiply that by 8. So now that would change that to -1 and 16 over 24. Now I can subtract. 21 minus 16 is 5. Keep your 24. And 4 minus 1 is 3. And it's more positive. So it's positive 3 and 5 24s. That was positive. That was negative. That's why we subtracted, guys. If they had both been positive, I would have added. They had both been negative, I would have added them, okay? And let's take a look at 10. 10, your X is on the right side of the line. And the number you want to get rid of is 4.8. But I see a division bar. So if you see division, then you need to multiply. You do the inverse, the opposite to undo it. Okay, so I'm going to multiply, but we do not change the sign on multiplication or division. So instead of dividing by 4.8, I'm going to multiply by 4.8. And remember, for multiplication, we use a little dot to show multiplication. Okay, so I'm over here, I'm going to put times 4.8. These are going to cancel. I'm left with X. Now to multiply decimals, let's see if you remember it. Okay, 4.8 times -1.6. You're going to multiply this as 48 and just do times 16 or -16, guys. And of course, you can use the smiley face, but we'll get to that in a minute. Well, we'll go ahead and take care of it. So you got a positive times a negative. So you know your answer is going to be negative something. All right, so I just need to do 48 times 16, but I'm going to count the number of decimals behind, the number of numbers behind the decimal. How many numbers is behind that decimal? 1. How many numbers behind this decimal? 1, which means I should have a total of 2 numbers behind the decimal in my answer. Okay? So I'm just going to do 48 times 16. 6 times 8 is 48. Carry the 4. 24 plus 4 is 28. And then in this particular case, I'm going to erase the 4 and then add a placeholder to start on the second number. And now I'm going to pretend like I don't see the 6. And now I know that 8 times 1 is 8. And 4 times 1 is 4. Add these up. That's 16. Carry the 1. That's 7. But I got to have a total of 2 numbers behind the decimal. So if I put the decimal here, I only have 1 number behind the decimal. So it doesn't go there. If I put the decimal here, now I have a total of 2 numbers behind the decimal. And remember, it's negative. So negative 7.68. That's fine. Say what now? Go ahead. Didn't you go earlier? You already went, right? Go sit down. I can't hear you. Do you have some type of stomach issues this morning? Your stomach is hurting. Is it an emergency? All right. I need to make a little note right here. When your number is mashed together with a fraction, you need to make this note. Multiply by the, what we call the reciprocal, which means you flip it, of the number with the variable. Okay? So when your number is mashed together with a fraction, no, let me erase that. Not when your number is mashed together with a fraction. When your variable is mashed together with a fraction. Like here, your variable is mashed together with the fraction -3/4. Why?
Do I need to?
I prefer you stay here and work on this since I'm behind. Okay. When your variable is mashed together with a fraction, I need you to multiply by the reciprocal of the number with the variable. Well, what number is with the variable? The number with the variable is -3/4. The reciprocal of -3/4 is -4/3. You just flip it. So since you have a fraction mashed together with your x, all I want you to do is multiply by the reciprocal of that. So the reciprocal of -3/4 is -4/3. But when I do to one side, I also do to the other side. So this is a special case, guys. So just watch for these, okay? All right, these are going to cancel, and I'm left with x. That's how you cancel those out. And then here, you have -9 times -4, which is positive 36. You're doing top times top and bottom times bottom, which gives you 3. Okay, 36 on the top and 3 on the bottom. And when you divide those two, 36 divided by 3 is 12. Okay? So, for instance, on number 12, I got a fraction mashed together with the x. So I need to multiply by the reciprocal of that fraction. The reciprocal of 2/3 is 3/2. But you're going to multiply by the reciprocal. Okay? Of that number that's with the variable if it's a fraction attached to it. Okay? So you got a fraction attached to x, your variable. Okay, when you have a fraction attached to your variable, multiply by the reciprocal, guys. The reciprocal of that fraction is over with the variable. So with the variable is 2/3. The reciprocal is 3/2. You're going to multiply by that. So I'm going to multiply both sides by 3/2. These are going to cancel. So now you have 3/2 times 1 1/2. Okay. We have a problem because with mixed numbers and we'll multiply, we need to change it to an improper fraction. You do not need a common denominator when you're multiplying or dividing. You only need a common denominator when you're adding or subtracting. So I'm going to just go ahead and change this to an improper fraction. 2 times 1 is 2, and then add the 1, we get 3. Okay? So that's 3/2 times 3/2. Now you can do top times top and bottom times bottom. That will give you 9/4. It's equal to x. And I'm going to have to erase some of this stuff. Make sure you're taking good notes, guys. If you need to go back and rewind it to write that, then go back and rewind it. All right, so this goes in and this goes out. All right, 4 will go into 9 twice. That's 8. Add a decimal and a 0. Bring that decimal up and bring your 0 down. 4 goes into 10 2 times. That's another 8. Add a 0 and bring it down. 4 goes into 20 5 times. When you subtract, you get 0. So this answer is 2.25. You could have also written it as 2 and 1/4. And I'm going to show you how. So make sure you have that written down. I'm about to show you how you could have written as 2 and 1/4. So you didn't have to change it to a decimal. I'm going to show you. You could have written this as 2 and then 1/4 like that. 2 and 1/4. But if you change it to a decimal, that's what it will be. If not, if you leave it as a mixed number, that's what it'll be. So what you'll do is you'll go back to the classwork tab and work on the practice. I'm sorry, there's 16 problems for the practice. Okay. Just work really hard for me. Thank you.